Hello everyone. In this video, I'm going to do some curve sketching examples. So let's start with this function fx is equal to x raised to power 6 minus 6x raised to power 4. And we're going to sketch this. So first thing that we're going to do is we're going to find the points where the curve gonna cross the x-axis. In other words, first step is find the roots of this function. In order to find the roots, we set fx equal to 0, which means x6 minus 6x raised to power 4 equal to 0. So x raised to power 4 is a common factor. So we get x squared minus 6 equals to 0. In other words, either x is 0 or x squared equals to 6, which means x is equal to plus minus square root of 6. So we got three roots of this function. Next, we are going to find the critical points, the points of maxima or minima for this function. In order to find the critical values, we're going to set the first derivative equal to 0. So let's take the first derivative of the given function. So derivative of x raised to power 6 would be 6 x raised to power 5, and derivative of x raised to power 4 is 4x cubed. So 6 times 4 is 24x cubed. So we set this equal to 0. So that implies 6x raised to power 5 minus 24x cubed equal to 0. And again we have 6x squared as our, actually 6x cubed as our common factor, and inside we are left with x squared minus 4. So if these factors is 0, it means either x equal to 0 or x squared minus 4 equal to 0, which means x equals to 2 or negative 2. So we get three critical value. So now we need to decide on maximum or minimum value. So for that, we're going to use our second derivative test because this function is very easy to differentiate again. So first I'm trying to use my second derivative test. So quickly I see that my second derivative is 30x raised to power 4 minus, so 24 times 3 is 72x squared. And if I notice that at the different critical points, so I'm gonna plug in. So let's plug in the value. So x equals to 2. So if you put x equals to 2, so you're gonna see that 30 times 2 raised to power 4 minus 72 times 2 square, and overall we get a positive answer. So positive means concave up, and which means we get a point of minima. So local minima at this point. And similarly, if you check at the other critical value negative 2 again, so plug in your second derivative and again you get a positive value. So again we get a point of minima because again it's concave up. And lastly, if I choose my third point 0, and I see that 0 minus 0, which is 0, so now our second derivative test is inconclusive. So we don't know whether it's the point of maxima or minima, so it means we should use our first derivative test for this critical value. So sometimes first, second derivative test works, sometimes it doesn't, but first derivative test always works. So I'm going to show you the first derivative test now. Not only for 0, I'll also show you for the other values so that you can see like it's optional. If you don't want to do the second derivative test, we could have just done the first derivative test for all three critical values. So we're going to start by setting up our table. So I'm going to write my critical values here. So my first critical value, the smallest one is negative 2. Next one is 0. And then the biggest one is 2. So I'm going to write them in increasing order. And then I'm going to pick a point to the left of negative 2. So let's pick negative 3. Similarly, you can pick negative 1, which is between negative 2 and 0. And you can pick 1 and 3. So after you choose your test points, you're gonna plug in the given function and the derivative of the function and see whether you get a positive answer or negative answer. So if I put negative 3 in my first derivative, I notice that I get a negative value. So this means the function is decreasing in that interval. And then if I plug in x equals to negative 1 in my first derivative, I get positive answer, which means increasing function in that interval. Again, negative means decreasing and positive means increasing. And based on that, we can, so decreasing, increasing. So this would be a point of min, and then increasing, decreasing, this would be a point of max, and then again this would be a point of min. So based on our first derivative test, we figured out that 0 is a point of maxima and other two critical values are point of minima. So that's our first derivative test. Since our original function is this, so at our critical points, we can figure out the values of the function. So f0 is 0, f of 2 is negative 32, and similarly, if you put negative 2 here, so you're going to get the same value. So these are our minimum and maximum values of the function. So maximum value is 0, and the minimum value is the negative 32. Remember, these are relative maxima or relative minima. It doesn't mean that this is absolute maxima for the function or absolute minima for the function. So now we are going to use all this information in order to draw our curve. So first we're gonna draw the roots of the curve. So roots are at the point 0, square root of 6 and negative square root of 6. Square root of 6 is approximately 2 point something, so 2.45. So I did the scaling of my graph and now, so the roots are 0, square root of 6, which is like 2.45, and negative square root of 6. So these are our three roots: negative square root of 6, 0, and square root of 6. Then we're going to decide on the maximum and minimum values. So maximum value, we know that happens at 2 or happens at 0. So maximum value is 0, 0, which is again this point. And then minimum values are 2, negative 32. Okay, so that's going to be somewhere here. So 2 and negative 32. So 2, negative 32, and similarly negative 2 and negative 32. So these is gonna be our min values. So now I'm gonna join these points together in the curvical form. So roughly this is what our curve gonna look like. So I just joined all the points together.